Alright, just wanted to solve this problem for you. It's a pre-calculus math analysis kind of problem, and it has a lot to do with the law of sines. So here we go. It says a straight road makes an angle A of 20 degrees with the horizontal. Just a little note, horizontal means, where's my little penny guy? Means this, like this way. That's the horizontal. When the angle of elevation B of the sun is 59 degrees, a vertical pole besides the road casts a shadow of 8 feet long along the parallel of the road. Approximate the length of the pole, round the answer to the nearest 2 decimal places. Alright, lots of information. Let's label. So, luckily, I have a picture for you right here, and it says a straight road makes an angle A of 20 degrees. So this is your road right here, and it's almost like we're Superman, and we can look through the road, and here's the horizontal right here. Everybody see my horizontal? And so this little angle in here is 20 degrees. So let me write that in because I need to make sure my drawing is labeled. It's a really bad picture, but that's okay. So with the horizontal, when the angle of elevation B of the sun is 59 degrees, so when the sun is at that, angle, and this is 59 degrees, okay, so angle of elevation means horizontal all the way up. Okay, so that's 59 degrees in there, so let me write all that is 59 degrees. A vertical pole besides the road casts a shadow of 8 feet long along the parallel of the road. Okay, so this is where I want to show you my shadow. So my shadow looks like this. Here's the shadow right here. It's 8 feet long. Doop, like that. Along the parallel of the, okay, so approximate the length of the pole. So I am definitely looking for this height of the pole. And here's my pole right here. Okay. All right. So now what am I going to do? I'm going to try to find a triangle. Hopefully he's a right triangle. And if he's not, that's not a big deal because I can do it with the law of sines. But I really like right triangles, and so I'm looking for right triangles. I see this big right triangle here, which seems like I don't know too much about. I see this little right triangle right here. So the first thing I want to do is I want to make a vertical with this right here, and there's many ways for me to do this. Just let me move him over here. Goodbye. Okay, so many ways for me to do this. So I'm going to draw this vertical line right here. Okay, and so this makes a 90-degree angle. If this angle here is the 20 degrees, how much is the rest of this? Okay, so that makes 70 degrees, right? Okay, if that's 70 degrees, so is this. You guys all see this angle. Pretend I like slid him over. So that's 70 degrees. And because I know that's 70 degrees, now this is where I just kind of go, because I know, then I know, because I know, then I know. Okay, so because that's 70 degrees, I know that this over here is 110 degrees, which is great because I want to find out as much information near this pole as possible. And because it doesn't look like I'm finding any right triangles with this pole, it seems like I'm going to be using this triangle right here. So let's try to draw them over here. Alright, so I don't draw very well, especially on the computer because it's harder. So I apologize. Oh, hey, that doesn't look too bad, right? Alright, so that's X. We just found this is 110 degrees. And this kind of could be 59 degrees. Now, is this 59 degrees? And the answer is no, because look, over here it says 59 degrees is the angle of elevation. So if I look angle of elevation, it goes from here to here. So that's definitely not 59 degrees. Okay, so nice try. I do know that the length of the shadow is 8 feet long. All right, so let's go 8 feet long. So that's 8 feet long. Okay. And if I could just find one more piece of information about this triangle right here, that means I can probably use the law of sines or the law of cosines. Okay, let me look at this more. I haven't used this 59 degrees, but I do see this right triangle right here. And I do notice that these two lines are parallel, or that he makes another like right triangle right here. Okay, so I'm going to look at this right triangle right here and say, okay, because you are a right triangle, that means that this is 90 degrees and that this is 70 degrees, right? And because it's 70 degrees right here, then that means that I can also use this right triangle, the big right triangle right here, right? So that 70 degrees is going to help me find this small little angle in here. So that is going to be 20 degrees. 20 degrees again? Yes. And there's many reasons why this is 20 degrees. Number one, we just showed you with the right triangle. And then number two, because these two lines are parallel, I get corresponding angles, 20 degrees and 20 degrees being congruent. Okay, so there's 20 degrees. Again, this is not 20 degrees. This other side is the piece that I want. But if I know the whole thing is 59 degrees and the part of it is 20 degrees, that means this leftover part is 39 degrees. This is lovingly called the angle addition postulate in geometry. And the angle addition postulate basically says this part plus this part equals the whole part, right? So now I have enough information from this right triangle that I can kind of like use my law of sines or law of cosines. So let's see, 39 degrees, 110 degrees. Hey, does that mean I can find the third one? All right, so that's 149 degrees. That would make this 31 degrees. Where are you? 30, oops, can't see you. Hold on. 31 degrees. So that makes that 31 degrees. All right, here we go. So 31 degrees. Okay, so if that's 31 degrees, right? So now I can fill in my law of sines. The law of sines is this this formula that looks like this, right? And it's A over sine A. That's big A. Big A means angle. Little a means side. B over sine B, and then big B, and then C over sine C. Okay, and so the way they're set up is the side opposite angle C is called little c. Okay, and so now I can set up my proportion, and I like to set up the whole thing, even though I can pick and choose exactly what I need to use. And I always start with knowing who I want to find out. Since I want to find out a side, I put all the sides on top. I put x here. And I'm going to use the sine of which angle. So if I'm looking at x, the length of this side, which angle am I looking at? 31, 110, or 39 degrees? Who's opposite of x? Good, 39 degrees. And then I've got 8 over, now which angle is opposite of 8 feet? That's right, 31 degrees. So sine of 31. Don't forget that sine. That's important. And then I've got this mystery side because I never labeled him because I didn't want to know him. And sine 110 degrees. And that's perfect. I don't need you. I don't need to have this information. But like I tell my students, I like to label all three to figure out which one's the best two to use. So now I have this proportion right here that I'm just going to cross multiply, get rid of the sine 39. Actually, sorry, I'm not going to cross multiply. I'm just going to multiply both sides by sine 39 to get rid of, sine 39 that we're dividing by. All right, so now I'm going to write x is equal to 8 sine 39 degrees divided by sine 31 degrees. Now these signs don't cancel because sine is a function. It's like think about like the square. Where am I? Think about the square root of 4 divided by the square root of 2. The square roots don't cancel because the square roots are functions. So the signs don't cancel as well. All right, so I plug this into my calculator. And I already did that work, so you don't have to watch me painfully plug it into my calculator. And I got about 9.78 feet. Really important here, my students make this mistake all the time. Let me change colors really quick because this is where my students make mistakes. On your calculator, you need to tell your calculator this is the beginning of my numerator and this is the end of my numerator. This is the beginning of my denominator and this is the end of my denominator. And also on my calculator, it gives me a parentheses whenever I enter sign. So just make sure you're closing that parentheses, otherwise everything gets, taken the sign of. Right, that's my explanation on trying to look for triangles in this picture. If they don't give you a picture, make sure you draw a picture. And then tip number 2, make sure you look for right triangles because those are always helpful.